In section 9.7, we're going to take a look at solving quadratics with square roots. Now, we already know how to solve them by graphing. We are essentially looking for the x-intercept where it crosses the x-axis. We also know how to solve them by using factoring, which we learned back in section 9.6. Now, this way is actually extremely easy to do, assuming the problem is set up in the right way. So, there are not all problems that you can do by solving with square roots. However, if we take a look at a problem like x squared equals 4, this problem is pretty easy to solve in your head. What you're thinking is, what number squared gives you 4? Well, most of you are thinking, all right, the answer is 2. However, keep in mind that negative 2 is also squared to become 4. So the way that we would solve this is we would actually go ahead and square root both sides. And we would be left with the answer of positive or negative 2. So that essentially is how we're going to attack this lesson today. There's going to be a little bit of algebra involved in some problems, but plain and simple, that's how we are going to look at it. Now, think about back to section 9.6. Let's start over here, and let's subtract 4 from both sides. Because I've always been a fan of believing the more ways you know how to do a problem, the better. If we're left with this, x squared minus 4 equals 0. If you think about factoring this is just a review. This is the difference of two squares. This would factor out to x minus 2x plus 2. What makes this equal to 0? Well, you could say that x equals 2. What makes this equal to 0? We would say that x equals negative 2. So once again, our two solutions would be positive or negative 2. Moving down to number 2, we just need to do a little bit of algebra. So once again, we're thinking about the square root of what number? The square root of 100. That gives me 10. And in this case, our solution would be plus or minus 10. So it required a little bit of algebra to get started. But then after we do that, we're going to square root both sides. Similar to the Pythagorean theorem, whenever you square root the side to find the hypotenuse or the missing leg. Now, let's just go ahead and do a couple other problems. Why don't you go ahead and try this one, number 3. So hopefully as you did it, you would have seen that we divide by 2, we take the square root of both sides, x equals positive or negative 6. Then I went ahead and I substituted my values in for 6 in for x, and I got 6 squared. 36 times 2, 72 equals 72. And because negative 6 squared also is the same as positive 6 squared, 72 equals 72 as well. Now let's move on to number 4 down here. Now we're going to do this one together because we're going to go through and do our usual move that we would have. And notice what we'd be left with. We have to actually find the square root of negative 36. So think to yourself, what number times itself gives you a negative 36? Exactly. Some of you are probably thinking, wait a second, that can't be possible. You are correct. There is no solution in this problem. This is actually what's called an imaginary number. So you'll learn that in 10th grade, Algebra 2, but in this case, you would simply write no solution and move on. If they asked you to explain this, you would simply say because you cannot take the square root of a negative number. Excellent job. Let's take a look at number 5. Now, in this case, I'm going to solve it 2 different ways here. I'm actually going to use the graphics calculator for you. After we do it using this method, divide by 2, x squared equals 16, square root both sides, and we get x equals positive or negative 4. Now, if this is our solution, positive or negative 4, that makes the equation true. However, let's think about it as an equation of a graph. So this is going to form a parabola, as we know from the beginning part of chapter 9. And I'm actually going to start with the same equation. But notice what I'm going to do. I'm actually going to subtract 22 from both sides so that I get 2x squared minus 32 equals 0. So from here, you actually could go ahead and factor and then solve for x that way. However, I'm going to think about it from a graphing calculator standpoint. So I'm going to take my equation of 2x squared minus 32, and I'm going to go ahead and graph this. Now I already adjusted the window so that the entire graph would fit on here. But take a look and think about, see if you can find the connection between the two solutions we found, x equals positive or negative 4, and the two solutions right here. So if you take a look at this, you're going to see that here is negative 4, here is positive 4. So solving this by graphing would work as well as solving with square roots. No chance that I would go through and do this problem by graphing. However, just wanted to make sure you saw the connection between what we were doing earlier in the chapter and what we are doing now. Let's take a look at one last problem, number 6. Now, this looks a little bit tricky, but watch what happens. We're left with x squared equals 49/16. Now, you're probably thinking to yourself, well, 49/16, ugly fraction, can't do it. Contraire, move for error. This is actually able to be done because think about it. If you square root both sides, we are allowed to break up the numerator from the denominator and take a look at it this way. Then I can go ahead and say that the square root of 49 is 7 and the square root of 16 is 4. And because I did take the square root and a negative squared is the same as a positive squared, I could say my solution was plus or minus the square, or I'm sorry, plus and minus 7/4. So once again, 9, 7, pretty straightforward lesson. Use it when you can use it. Not always are you going to be able to. However, take advantage of it when you can. Best of luck.